Okay, question 7. Figure 11 is the symbol for the nucleus of americium-241. It emits alpha particles. Okay, lovely. Which of these is the symbol for another isotope of americium? So ultimately, it's got to have the same bottom number of 95. Sorry, not bottom number, same smaller number or atomic number. And it's got to have a different mass number. So it can't be you, can't be you, can't be you. Must be you because you've got the same atomic number. So C, and a different mass number. Which of these is the approximate distance that alpha particles can travel? So I taught you it's about 1 to 2 centimeters ish, and we're just going to pick something around that. So maximum distance, B, 5 centimeters. Next one, complete the equation for americium-241 decaying into neptunium. So it's testing, you know that this has got a mass number of 4 and a atomic number of 2. Ultimately, I could put all of that as a 2 plus charge as well. Then if we know that that's this side must equal that side, so 4 plus something must equal 241. That's got to be 237. 2 plus something must equal 95. That must be 93. So there you go. So you've got to know those. Remember, beta minus, beta plus, gamma radiation, doesn't have anything, and a neutron is 0, 1. There you go. So that's quite nice questions. Next one. The activity of a radioactive source is measured at 128 becquerels. We can see that there. That's its initial radioactivity. The half-life is 17 seconds. Use this to plot 3 more points. So what we've got to do is measure 17, measure 17, measure 17, measure 17, and then each time half it from 1 to 8 to half, to half, to half, to half. And we should end up with a curve like that. So there's the basics. So half 1 to 8 and move on 17 seconds, then half that, move on another 17 seconds, half it again, and then, oh my god, that line of best fit's a bit pants. That's not perfect, but it'll do. Clearly that's garbage because it's going. There we go, that's a little bit better. Okay, so I'm sure that made sense, it's quite nice. Describe what happens in the nucleus when a positron is emitted. So we know beta minus, beta plus. I taught you sex change in terms of what's going on. So we said in beta minus, a neutron changes to a proton and an electron that's emitted. And for a positron, a proton changes to a neutron and a positron, which is emitted. So the antimatter for an electron. So a proton changes to a neutron and a positron is emitted.